It's a very rainy Sunday afternoon, as you might be able to hear, and I'm up the shop doing what anybody would do on a Sunday, trying to determine what the power consumption of a GPS and satellite tracker is for high altitude ballooning. So let's take a look and see how we're going to do it. So this is a custom piece of hardware that we build for the National Severe Storm Laboratory. It's got a GPS on it and an Iridium satellite transmitter, and it uses one of our pull pin switches. So when the pin is pulled, everything powers up and it gets the position of the instrument on a fixed time schedule and transmits it via Iridium. Now they do this so they can track high altitude balloons and retrieve the payload and the data and fly it again. Well, we want to make this last longer on a battery. We're trying to run it on a single lithium 9-volt, that's the goal, and ideally we can get 24 hours out of this. Now I think that's going to be a stretch, but we're going to instrument this up so we can find out exactly not just what the current draw is, but what the current profile is, and see how long it will really last on that single 9-volt lithium. Now these are the batteries that we're going to be testing. The Energizer 9-volt lithiums, partially because this is going to be, even though it's insulated and some foam, it's going to be on a high altitude balloon, so it's going to get cold. Also, these have a better energy density and they're not rechargeable. They are disposable, so we don't have to worry about limiting the discharge and keeping batteries charged. The biggest downside is the cost. These are $15 a battery. So this is a $30 pack of batteries. So I really only want to do this test once. I want to know how much I can actually get out of these batteries, and I want to know how much current this pulls during its different phases, when it's idle, when it's transmitting, when it's getting a position lock. So we're going to add some wires to this so we can instrument and measure the battery voltage and the current draw, and with that we'll be able to answer all of our questions. Okay, so looking at the device here and how we're going to do this, the way you measure current is to break one of the power lines and put some current transducer in there. I'm going to use the microcurrent gold from EEV blog. This is just a handy low burden way to measure current, and it turns, in this case, 1 millivolt into 1 milliamp. I'm going to leave it set on that scale and turn it on. It's powered by a CR2032 that will power it for as long as this test needs to go. We put the current through these terminals and it outputs a voltage on these that will log. And I need to log the voltage of the battery. So after taking a look at this, I think the easiest way is in here on the bottom of the circuit board, I'm just going to break that positive out and put a couple extra wires on for my current sensing. And then I'm going to tack on a positive and negative wire to measure the voltage with my analog to digital converter. So let's get some wire and do that. Go ahead and get my solder here. We do everything lead-free now. Honestly, lead-free solder is not a big deal anymore. So I'm gonna tin the wire here. Get the wire hot and let it melt the solder. Okay, and now the tricky part's going to be getting it into the board because it's relatively tight. Okay, so that's going to give me the 2 wires that I need to go across the microcurrent here. And now I'm going to tack on a couple of wires down here. So same thing, I'm going to go ahead and tin those. And I'm going to trim them down some. Again, these only serve so we know what the battery's voltage is as it's discharging. I can make our own discharge curves. And then if we make any future software changes, like how often we're sending packets, let's say, we can just simulate what that's going to do instead of have to run this test again. Okay, so those wires are all tacked on. Go ahead and route everything with a little bit of tape for some strain relief for the test, and strip these ends. Okay, now I'm going to go ahead and put these into the microcurrent. I don't know if you can hear, it is really raining outside. We got our microcurrent, our battery will go there, and we've got our voltage sense leads. So now it's time to go get the data logger. So I'm going to be using one of the data loggers that we use for our Gears workshop. We created these as a student tool, but honestly, we use them all the time for things around here, just like this. So they've got a LabJack T7 and a Raspberry Pi with a touchscreen, a keyboard in case we need that, solar charge controller in case we want to power on solar. There's cable ports to get power in and out and sensors in and out. But what we're going to do is set this up with the LabJack to read the voltage and the current of the battery and log that. It's also going to send it to our online field watch service so I can check on the test remotely. And then I'm just going to set everything in here. There's a big area in here where I can set everything down and seal it up and just let it go. So this should transmit through the plastic lid. Everything should be great, which is good because it's raining outside right now and I want something that's going to be weatherproof. And then we'll test it with a non-lithium battery to start with, not for the full duration, just to make sure the whole setup's working. So the first thing I'm going to do is go ahead and get the Raspberry Pi booting up. So to do that, we're going to run on wall power. I won't put it through the feed through right now. We'll do that when we deploy this outside. Okay, so we'll get that booting, grab the screwdriver out of here. And let's see, I'm going to set this, and we'll just set it down in here. Okay, I may not have given myself enough wire lead room, so we're going to have to set it up here maybe. Connects the battery voltage to analog input 1, and let's see, we got battery ground. Okay, those are good. This analog input is going to be the voltage output from the microcurrent, so our current monitor. You know, it's raining hard, but it's not as hard as it sounds because there's just a little bit of insulation on a metal roof here. I really like the sound. It's just not great for trying to record videos. All right, that's all set up. I'm going to turn the microcurrent on, and I'm going to open our data logging program, and I'll show you what that looks like. This data logging program is really simple. I just activate the 2 channels that I want to be activated, analog in 0 and 1. I set a rate, 1 hertz, every 10 seconds. 1 hertz is fine, and I hit start logging, and it tells me how many rows it's logged and what the voltages are. So I'm going to go ahead and plug a battery in and see what happens. Now again, I'm going to just use a regular battery for now. I didn't like that. I was seeing a very low voltage on this battery, so let's check this battery and see what it's at. All right, so the battery should be reading 8.8 volts. I'm not sure why we're not seeing that. I don't see anything that's miswired. Okay, we're going to put a pin in, which is going to shut off the instrument and just make sure we can read battery voltage, and then we'll try turning it on again. Okay, so I'm putting a pin in. That's going to mean that we will not power up the unit, but we should still see the battery voltage the way I've got this set up. Yeah, I'm not liking what I'm seeing here at all. So I'm going to take the microcurrent out of the equation. I'm going to put it in short mode. See if we get a battery reading. Okay, now I get a good battery reading. What if I turn the instrument on? Yeah, I see a voltage drop. That's expected. Okay, so something about the microcurrent being in circuit here is not jiving well. Okay, so what we're going to do now is we're going to take our battery voltage monitor loose and put the microcurrent back in circuit. I have a feeling this is an issue with the fact that the LabJack is sharing all of the grounds. Okay, so I'm going to disconnect my battery voltage monitor leads. So now we're just doing current monitoring, and I'm going to stick a piece of tape over that positive because it will have the 9 volts on it. Okay, I plug the battery in, turn this to the on position. We're seeing 0 readings. I pull the pin, and we're seeing about 0.3 amps. Yep, so that's what I expect. Okay, so the problem has to do with the fact that it does not like the shared ground, and we should be able to verify that by just touching it. Okay, so that didn't seem to be a problem. I'm gonna put that in. Maybe we just had something that wasn't connected well. Oop, nope, I heard sparks. Okay, yep, that is the shared ground issue. So when I try to put that ground in, it is causing a problem through the lab jack, and luckily it looks like it's survived that problem. But we're not going to be able to monitor the battery voltage and the current with this particular setup, which is unfortunate. Well, current is what we need to know the profile of, and the battery voltage is probably not going to be nearly that important. So we'll stick with that. So I'm going to stop logging and turn my second channel off. I'm going to go ahead and remove those extra wires just so they're not in the way, and we'll see if we can get this deployed. This is one of those things where I didn't really put a lot of thought into the test setup beforehand. I just wanted to get something working really quick. And yeah, sometimes things like shared grounds, especially when you've got, a ground reference from the wall for that, which is ground reference for this, then we've got a battery, and then we've got this unit. Sometimes things can sneak in on you, and that's okay. I care a lot more about the current profile. So I'm going to now connect my battery up. Okay, it's running. I'm going to switch this to on. You can tell we've got an LED blinking on there. So yeah, right now we're pulling 0.3 amps. Now it's coming down as it's not transmitting. We've charged the super cap on the Iridium modem up, and now it's coming down even more. We're in the 40 milliamp range. And now it's trying to transmit, which it's not going to be able to do because we're inside the building. So this test setup is going to work. I'm going to secure everything down, and then we'll put a real battery in it and see how long this thing can last. Okay, so right now it's still really heavily raining and the radar shows no signs of stopping anytime soon. Though this is fully weatherproof, I don't particularly want to be trying to get out there and deploy it and start the logging in the rain. It's just not pleasant, and it's not necessary because tomorrow it's supposed to be just fine. So I'm gonna go ahead and get it all sealed up, all ready to go, and tomorrow morning I'll go put it out, assuming that the weather has indeed abated as they predict. And so stay tuned. We'll make that part 2 of this video, and we'll collect some data. We'll look at that data using Python and see exactly how much power that this thing draws.